Okay, so today we are going to take a quick walk through basic tension problems. So for example, let's say that we have a traffic light, right? And it is suspended from two cables. And let's say that these cables happen to make different angles with whatever it is that they're supported with. So let's say that this is a 78-degree angle on the left side, and that we have a 60-degree angle on the right side. What we're looking at is we're wanting to know the tension in the cables that are supporting it. We don't know what that is, so we will call this T1 and we'll call that side T2. For this problem, let's say that not only do we know the angles, but we also happen to know that the traffic light is 32.5 newtons. So what that value is telling us is that the traffic light itself weighs 32.5 newtons. So we can do a down arrow, and then to signify that it's actually going down, and we remember that it's going down, you can put it in as a negative 32.5 newtons. Okay. So where we're going to go from here is we're now going to find the tension in each of these cables. At any point in time, you can stop the video to take notes or rewind it if you need to. So the first thing that I'm going to do is I'm going to analyze each one of these cables. And if we've got this one over here, the first thing we need to think about is what direction is that cable pulling in. So if the traffic light is being pulled down towards Earth, then this cable is going upwards. The reason why that's important is anytime we have something going in an angle, you're going to need to break it down into its x and y subcomponents. Okay, I'm just going to break it into its x and y subcomponents on the outside of this, just because there's more space over here for me to make my drawings. And then because this and this are parallel, if this angle is 78, then this interior angle is also 78. Okay, so now what I'm going to do is I'm going to try to solve for the subcomponents of T1. Now the x side right here is going to be cosine of 78 is equal to the adjacent side over the hypotenuse. My hypotenuse in this scenario doesn't have a number, it's a variable T1. Okay, we're getting ready to carry around a lot of numbers with us, so let's just pause for a quick second and let me grab a calculator. Okay, so to make the math a little bit easier to keep track of, what we're going to do is I'm just going to go ahead and turn this cosine of 78 into a decimal number. So just enter into your calculator cosine of 78. And it's a small number, so I'm going to take the decimals with me. Okay, so that is 0.208 is equal to the adjacent over T1. Now I'm trying to solve for that adjacent side, so what I need to do is multiply by the reciprocal to get rid of it. And basically what I come up with is that my x side for my picture is going to be 0.208 T1. Okay, as soon as I've got that value, I'm going to put it in my picture. And I'll notice in my picture that that vector is going to the left, so I'm going to make sure that I label it as a negative. Okay. Next, let's repeat the process to find the y component. So for the y component, we are now sine, because it's the opposite side. So opposite over hypotenuse. Once again, I'm just going to multiply so that I can get rid of that. And I want to make sure that I put this number right here into decimal form. So the sine of 78 is going to be 0.978 T1. That's going to be equal to that y side, my opposite side. So I'm going to come over here to my picture, and I'm going to put a positive sign there just to make sure I understand that it's going up. Okay. Now what I'm going to do is I'm going to repeat this process for the other side. Now on this side, again, this cable right here has to be pulling upwards since the weight of the traffic light is going down. We're going to take it, we're going to break it into X and Y, and since these lines are parallel, if that's 60, then this angle right here is also going to be 60 degrees. We're going to repeat this process again. So on this side right here, this would be the X component. That is going to be cosine of 60 is equal to the adjacent over, and this time the hypotenuse is T2. So I'm going to go ahead and convert cosine of 60 into a decimal number so it's easier for me to keep track of. And we're going to say 0.5 T2. So the X component there is going to be the cosine of 60 times T2. I'm going to go ahead and put that in my picture, and since I'm going to the right, I'm going to label it as a positive value. Now I'm going to do the Y component. That's the opposite side. So we'll do sine of 60 is equal to opposite over T2. And again, let's convert that into a decimal number. So the sine of 60 is going to be 866. So the Y component on that side of the triangle is going to be 0.866 T2. I'm going to put that into my picture. Okay. All right. So now that I've got my picture labeled and I can clearly see that I've got all these vectors going everywhere, what we're going to do is we need to add them together. The easiest way to add them together is to go ahead and make an XY chart. So, another piece of paper here. Okay. So what I'm going to do now is I'm going to make an XY chart with the information from my picture. So X, Y. Okay. What we have here on the X, there's a negative 0.208 T1. On this side of the X, there is a positive 0.5 T2. And make sure you're taking those T1s and T2s with you. On the Y side, over here, I've got the positive 978 T1. And on this side, I have the positive 866 T2. All right. At this point, you might think that you're good, that you've captured all the vectors, but don't forget that one right here, okay? So if these were the only components acting on this, then this light would be going upward. So we have to counter it with this force right here. Notice that it's going in the vertical position downward. So we're going to put it on this side, this negative 32.5. All right, the next big thing to understand is what's going on with this traffic light. In a normal situation, it's just going to be hanging there. That means that it's still or stationary. If it's still or stationary and it's not moving, what can we conclude about the net forces? That's right, the net forces are going to be 0. So whatever's happening in the X direction, if you add all of this up, it adds up to 0. Whatever's going on in the Y direction, if you added all those up together, that would also be 0. Okay? Now this is really important because what we're going to do now is we'll be able to take that information and we'll be able to start setting up equations. So my first equation is going to be my X components. Now, because that's a negative, I'm just going to start with my positive value. It's just a preference so that I don't forget it or lose track of it when I'm doing my math. So there's my first equation. And then my second equation will be all of those Y components added together. You can just go ahead and list that as a negative 32.5. And all of that is going to be equal to 0. Okay. So once we have that equation, make sure you got that as a negative. once we've got this equation, what we've got going on here is we've got two equations and two variables. So what we're going to do is we're going to solve for one of them and do some substitution. So what I'm going to do is I'm going to take equation 1 and I'm going to rearrange to solve for T1. So I'm going to take this equation and I'm just going to start doing my algebra, and I'm going to start solving it so that T1 is the only one that's left on this side of the equation. So let's go ahead and move that component over. So that gets rid of it. And then once I'm set up looking like that, what I want to do is I need to isolate T1. So I'll divide both sides by the negative 0.208. Whoops, not the variable, just the number. Okay, so once I've got that, that means I'm just going to divide these together because this gets canceled out on that side. And I'm going to come up with a value of 2.40 T2 is equal to my T1. Okay, so the T1 is equal to this number times T2. That's really important, so circle it. Okay, and let's go ahead and continue with our second equation. Okay, with the second equation, what I'm going to do is I'm going to take it, and what we're going to do now is we're going to do some substitution. So what I'm going to do is I need to make sure that if I've got one equation, that everything's in the same terms. So what I did is, since I've got T1 right here, I've got a T1 right here, I can take this value for T1 and I can actually substitute it. Okay, so now we're going to substitute. So this becomes the 2.40 T2 instead of that T1 number. And we'll just keep going on with our equation. Okay, so the first thing that I'm going to do is this guy's not like the rest, so I'm just going to move him to the other side of the equation. So all we're doing now is just basic algebra. Okay. Next, what I'm going to do is these guys are multiplied, so I'm going to go ahead and multiply those together. And then I can see clearly that these are the same variable, so now I can add those together. And then from there, I can just divide so that T2 will be isolated. That'll get rid of that number. And I get a T2 of 10.12 newtons. I'm putting it in newtons because I was solving for the tension in the second rope, okay, or the second cable, and the tension is the force. That's the force that that cable's holding. So what we just saw for that 10.12 is, if we go back to this picture, the 10.12 is this right here. That is the tension in this cable required to hold up that traffic light. So what we can do now is, this last step is super fast, is we can go find what this cable is doing, and we're going to go back to where you circled this guy because he's important. All we got to do is take this value down here for T2, which is the 10.12, and put it right in there. So what would be 2.4 times 10.12? That gives us a T1 of 24.29 newtons. Note that right there is the tension